Hello class, in this video I'll be showing you how the average rate of change and the instantaneous rate of change can be applied in a business setting. And at the top of the page I have provided the average rate of change formula and the alternate form of the instantaneous rate of change formula. Let's begin. The revenue in thousands of dollars from producing X units of an item is R of X is equal to 10x minus 0.002x squared. Find the average rate of change of revenue when production is increased from 1,000 to 1,001. Since the problem is asking for an average rate of change, we are going to apply the average rate of change formula. We can use Decimus to evaluate R of 1001, and when you do, that is 8005.998. R of 1000 is 8,000. And when you're done with the arithmetic, the result is 5.998. And we have to be careful because revenue is in thousands. So the revenue is not 5.998. The revenue is actually 5.998 thousand dollars. So what does this number mean? Well, this number means that revenue will increase by exactly $5.998,000 when the number of items produced increases from 1,000 to 1,001. Now we can use the word exactly because in this case we're given 2 points to compare. So when we interpret the number 5.998, that is an exact increase and not an approximate increase. Part C. Find the instantaneous rate of change of revenue with respect to the number of items produced when 1,000 items are produced. So we're going to apply the limit definition for the instantaneous rate of change, and we're going to use the alternate form. So R of B is equal to 10b minus 0.002b squared. And from part A, R of 1,000 is 8,000. So we want the limit as b approaches 1,000 of 10b minus 0.002b squared minus 8,000 divided by b minus 1,000. Now I'm going to write the numerator in descending order. Okay, so the numerator does factor, but before we factor the numerator into two binomials, I'm going to factor out a 0.002. I'm actually going to factor out a negative 0.002 first. So that becomes a b squared minus 5,000b plus 4 million And we're going to divide that by b minus 1,000. Now, the numerator looks like a pretty challenging trinomial to factor. However, if you look at the denominator is b minus 1,000. So I'm going to assume that one of the factors of the trinomial that I just highlighted is going to be b minus 1,000. So this is the limit as b approaches 1,000 of negative 0.002 b minus 1,000 times b minus, now to get 4 million, you have to multiply 1,000 by 4,000. And there is your second binomial. That's b minus 4,000. And you'll notice that there's a b minus 1,000 in the numerator and a b minus 1,000 in the denominator, and they divide to give you 1. So this is the limit as b approaches 1,000 of negative 0.002 b minus 4,000. And substituting 1,000 in for b, that is negative 0.002 times negative 3,000, which happens to be 6. And since the revenue is in thousands, this happens to be 6,000. Which happens to be just $2 off the first part of 5,998. Yes, that answer is really close to our answer in part A. But what does that number actually mean? That means revenue will increase by approximately $6,000 when the number of items produced increases from 1,000 to 1,001. And the reason why this is only an approximation of the increase in revenue is because the problem only gives 1 point to evaluate. In the previous example, again, there were 2 points to evaluate, so we can compare them and get an exact increase. Since there's only 1 point in this problem, the solution that we get is an approximate increase. And again, this is a pretty close approximation. I think you're only off by $2.